Hey, we're back. Got my tea. We got our friends. Hi, everyone. And we're finally going to get into doing the multiple trials that I've been kind of hinting and promising for a while. But first, we are going to have to review basic pivot tables. I'm sorry, basic data tables. That's how we're going to do this. So here's a very simple, outright trivial model. Now, here's an outright trivial model that we have the input hours, hourly pay, we compute the gross pay, we have an input for the tax rate, and we compute the net pay. And the net pay is what we really want to know about. And we can say, well, what if I work 16 hours instead of 10 hours or 22 hours? Well, again, this is fairly trivial, but a data table will do that calculation for us. So you feed the first row of the data table. I don't normally in a data table necessarily mark these. I'm going to just give it a different shade because that's the feed for the data table. And then we select it, and we're doing one-way data tables. So it's a what-if analysis. And it says column input cell. If you remember what a data table does, it's going to take this column and take every element in this column, put it somewhere on the spreadsheet, and then take the output from this value and fill it in. So I want these numbers to go into there. So into cell A1. And there we go. It didn't format it for me, but it's done. So this is the original, and now this has that table thing. So what it did for me, it cycled. It essentially put 10 here and put that value. Then it said, oh, I'll take this off, so it won't let me change it. Then it went and put 12 over here and said, oh, okay, now the value is $100.32. Then it put 14 in here and said, oh, okay, it's $117.04. And then it put 16 in here. And it does this all the way down. And then when it's all done, it goes back and puts whatever it started with. I just didn't do them all. That's what a data table does. And that's what we're going to use for simulation. And it's kind of a cute trick how they do it. So look at your data table stuff. Take a quick break if you need one. You should already have these open on your computer, so we'll just kind of do them in order. Problem 2.2. We built two models, a uniform distribution and a normal distribution. Now I tend to, in my simulation models, put a big, thick, black column between my single trial and my multiple trials. It's just a habit of mine. You don't really need it, but I like it. It separates. And eventually I put a big, black, thick column here, and over here will be our statistical analysis. So, to do a multi-trial model, we had to decide how many trials we want. And I mentioned before, 500, 1,000. You just number them for however many you want to do. There's no magic to the numbers 500 or 1,000 or 100 or 10,000. You could do 763. We generally figure between 500 and 1,000 is plenty. If we have time later, we'll talk about how to narrow down that you may want a specific larger value. I'll just do 1,000 here. People like thousands. People like round numbers. And you can kind of see the numbers counting up, so I keep autofilling, dragging down. Oops, a little further than I need. There. So now I have a column of just values. And my data table, I feed it with the output of this model. Just like any other data table that's getting fed that way. Actually, let me real quickly move this file out of my way. And I could, again, You don't have to, but I kind of like sometimes in data tables somehow signifying that's the input and the rest of this is the output. Now remember what the original problem did, the original data table. It would take this value, stick it here, which would recalculate all of these, take the output of the calculation, put it in here. I have this set so when I do pretty much anything, except, remember the settings, set the data table, it recalculates. So if I go over here and do equals 5, there's a recalculation going on there. That's what the data table kind of does. It takes this value and puts it someplace, makes it equal somewhere. I just have to tell it where, and I can put it anywhere. I go over here and say, make this equal to that value. Notice the model changes. Make this equal to that value. The model changes. So in a normal data table, we feed these values into the model. All I have to do here is feed these values into a blank cell, and it will recalculate this one trial simulation and populate this with the output. So let me show you. Just like any data table, you select all the material. Oops. When it's 1,000, sometimes it's hard, so often I go to the bottom and select up. Data. What if analysis? Data table. And it's a one-way data table, so it's where do you want to put this column? You can put it anywhere. You put it at the end. I'll often just find any empty cell. Oh, I selected too much. So let me pause this. Okay, so once you've got this set up, you select all the way down. You go to Data, What If, Data Table, and it says this column, where are you going to put those values? It can kind of be anywhere. Any blank cell works fine. They're not formatted, but there's the output. Sometimes I'll even color code it's not really blank if I call it blank, but you can go that far just to remind you to click that's where the stuff goes. Now I'm going to go ahead and format this entire output. So now I have 1,000 trials of what might happen to the auction house. So I'm not going to do the real statistics yet, but just the obvious questions you might have. What's the best they did in 1,000 random trials? What's the worst they did? So I'll throw those out real quick. So the worst case they had on this is they lost almost $36,000. The best case they made about almost $29,000. That looks like there's more risk than reward, but we don't know the distribution. The distribution could be very strong towards positive values, or not so strong. Of course, this was modeled with the sale price being a uniform distribution. Just for practice, let's go do the same thing over with a normal distribution. And we'll do a full statistical analysis in the next step. I just wanted to show you that you can do it, but our goal today is just getting these random trials. Where did I put my E? Okay, I'll be consistent. I'll make E my barrier cell. I kind of like having the blank. So I'm going to do it again. I'm going to call a cell blank when it's obviously not blank because I put a word in it, but I'm going to do it anyway. Like I said, there's no magic to the 1,000, so I'll just do, I'll do 1,000 anyway. We'll do 500 on a different one. So again, whether or not you wish to code the feeder of the data table or signify it with color, it's up to you. But once you've got the single trial model, which was where a lot of work was done, you set up just your 1 through 1,000 numbers and give it one feed. Getting the multiple trials part really isn't all that difficult once you remember the steps. So I want this column to go into a blank cell. I could pre-format the column, I suppose. Might look nicer. Or I might not care. This might be something that, depending on who's going to see my output, that the formatting, or that this individual output might not even be seen by my boss or my client. It might be that the stuff over here is all they're going to see. So the format might not matter. It's up to you in that regard. So at least at the extremes, it's pretty close. I'll take them off of there. Was in the mid-30s was our worst loss, and a little bit higher max, but basically mid-20s was the best gain. We don't know the distribution yet. That's part of what our job's going to be. But for today, if you can get the multiple trials working, and now if you want to get a different, this is kind of meta, I guess. Remember, this is a single trial. This is 1,000 trials. I just did another 1,000 trials. Every time I hit F9 now, I'm getting 1,000 new trials, not just one trial. And this, by the way, is why we turned off the auto recount, because otherwise if I did this, no, I actually did not turn it off on this computer. I've changed computers. I'll have to turn it off. It's going to start bogging down. But I'll be okay because I'm going to close this and open up the next example. Auto leasing. This was a more complicated model, but getting the simulation part won't be that much more complicated. Our question is, and we can look at one at a time, if we plan to keep the car at the end of the lease, is leasing cheaper than buying or more expensive than buying? We can actually look at the dollars, or we can just look at the yes or no question. We're running out of space. I'm going to have to go way over here to do my barrier. So we'll do one of these at a time. The trial, the keep present value of a lease, one, two, three. We'll just do 500 on this one, just to show you the difference. And when we do the statistical analysis, we'll run through what 500 versus 1,000 does for my estimates. And you can decide if you think you need 1,000 or 500. For now, just for contrast, we'll do it both ways. So we're working on just this possibility. So what's the present value? We feed it with that present value. And this is more than buying. So that's the feed into my model. I'm going to have my blank cell, because I always have a blank cell. Notice I don't select these headings, I select this value to feed into my data table. Select all the way down. It's hard to see because my little screen's in the way, but you can see the numbers, I believe. This part you'll get used to because it's actually kind of automatic after a while. Feed the column into the blank cell. This one, you'll notice, did not recalculate, so I do have the recalculation stuff set correctly. I want everything centered here. And this one, so F9 gives us a whole set of new present values for the lease, and since there's 500 of them, I'll just do one quick calculation. The estimated probability of less. I'm counting how many times it say it's less than buying, divided by how many things there actually are. And this one came out 50%, which frankly seems a little higher than I expected. So about half the time. It's coin flip. If we want to do, remember, that's if I'm going to keep the car. If I'm going to get rid of the car, I have to do a different comparison. So, trial. Dump. Well, here we kind of need both, though. We need the present value of the lease and the present value of buy and then sell. I'll just do 500 trials again. The present value of the lease comes from up here because it's just leasing, there's no buying at the end. The present value of buying and selling we had over here. And then the more or less we pulled out of there. Leasing is more. I would probably want to make somewhat more clearer labels in this. I don't know that I love these that much, and I'd probably insert an entire row here explaining that this is, again, the whole problem if I'm going to eventually keep the car versus I'm going to dump the car. That kind of stuff would have to be in there. But right now I just want to get the mechanics down. And the mechanics are pretty similar. I already had a blank cell marked blank. I'll just use the same blank cell. Format this to be a little bit nicer. And I can ask the same question. What's the probability that's a better label. not very high. If you are just going to get rid of the car at the end of the lease, according to this one, you're better off actually buying it and then selling it in 2 years, 99% of the time. Let's get that one out of the way. And the last one, trivial training. Nope, not trivial training. Sorry, wrong problem. We will look at this one. Real estate. Remember we did the worst, best, average case, and it did kind of look like you should sell now. Well, the simulation model let's put these back to the 95% they're supposed to be. If they aren't in the file you downloaded, do that. That was the original data. We were playing around with it. And over here, I was just showing you how to do, or Stat actually came up with that. My idea! I'm showing you how to do it in one formula, if you preferred one formula. They knew it was your idea, Stat. They remembered. I certainly hope so. So, what's the market value a year from now? Oh, just for kicks, I'm going to do $868 trials. This is really completely up to you. Right now, we're not worrying about margins of errors on estimates yet, so a lot is a lot. And 896, 868 is a lot, just like 500 or 1,000 is a lot. That's all we're worried about is this market value, what's it going to be in a year, and a random outcome in a year. If you like the color coding for the feed row, you can do that. It's actually not necessary, but you can do it. So I have 800 something. I don't see a whole lot of numbers bigger than 2 million. If I see anything bigger than 2 million, let's find out. Okay, there's one bigger than 2 million. Well, the average is quite a bit lower. So let's go back to our static, by the way. Our static said the average would be about 1687. Look at our average over almost 900 trials, 1687. Our static model said the possible best case was 2.1 million. Our best wasn't even there. And just for kicks, let's look at our worst. Our worst is under 1 million. The static model worst would have been only 500,000. That was really, really bad. A lot of things had to go bad for that worst model. So in almost 900 simulations, that didn't all happen. So I'm obviously already cheating and doing a little bit of statistical analysis, but we'll save that off. I just want to show you the possibilities. But that's the process. So we have our single trial models, some of which are very complicated. We spend a lot of time building this particular one, some of which aren't so complicated, but then we do the multiple mini trials output, and we're going to do analysis on that. And I could put more here. I could have put a less or more. Market this value less or more than the previous year, and I could feed that into here. So you can make this a little more complicated, but this is what we need to do for now. Now, the one you're doing on your own, I'm not going to show you how I did this. I didn't show you how I did this last time. Randomly putting those inputs. So here's your units sold, here's your sale price, here's your revenue. These are just calculations using the cost data. And then we would feed one row of this, and I'll let you figure out how to get. I did 960 trials. Again, I was just being contrary. I'll show you later how to do that, but you should be able to do this part on your own. Now, go try the trivial training example on your own, and then go on to the next video.